Guys, and welcome back to Mr. G Physics, the channel that can help you to improve your marks in physical sciences from grade 8 to grade 12. This is Mr. G, and today we're going to be solving a question on organic chemistry, the reaction that can really give headache to the children. But before we carry on, don't forget to subscribe for the channel so you can get the notification and all the videos I post on regular basis. So this question said, bromine water can be used to distinguish between saturated and unsaturated compounds. Equal amount of hex2in and hexane are added to respective test tube A and B at room temperature. 2 cm cubic of bromine water is added to each test tube. Shaken. The solution is in test tube A becomes clear, while the solution in test tube B has a brownish color. Question 4.1. What it mean by unsaturated compound? And let's go here. What is a saturated compound? There is only single bond between carbon. Alright, the word between carbon is extremely important. You can never forget the word between carbon. Now, a saturated compound is that organic, we're speaking about organic compound, is that organic compound that have only single bond between carbon atoms. In this case will be the alkanes. So, which one is the unsaturated? It's the one that could have one or more multiple bonds between carbon atoms. Is the one that can have one or more multiple bonds between carbon atoms. Also, the part when you say between carbon atom is important, guys. If you forget that one, you won't get the mark. Now, using the structural formula, write down the equation for the reaction in test tube A. Okay, so now if we analyze this reading real fast, we can see that the reaction in test tube A became clear, while the reaction in test tube B has a brownish color. That is the color of bromine water. It means the reaction did not happen in test tube B, but test tube A did have a reaction because the solution became clear. So in test tube A is when we have a unsaturated compound, and then that is also where the reaction is going to happen. So let's see how to write this specific reaction. We have hex2in, that is the organic compound here. Let's write it here. You have hex2in and then you in bromine water, which is Br2. So we're starting with alkene, with an alkene that have a double bond in carbon 2. Okay, we can see the double bond here. Now, since the moment the reactant have a double bond, this is going to be addition. Okay, nothing to say, it's going to be addition. Now, we are adding bromine, so it's halogen. So what type of addition are we having here? Halogenation. This is not part of the question, but we're just trying to get as much information as we can. So what is going to happen? That double bond is going to break spontaneously, and the Br are going to take that place there. So here we have the 2 spaces, and each space will get 1 Br. This is halogenation. It's quite simple. I hope you understand this question. It's tricky because of the first part of the question, in which they say they're adding the bromine water and the color change. You need to know that bromine water has a brownish color. So the one that became clear is when the reaction actually did happen. Let's go to question 4.3. Give a reason for the observation in test tube B. Now, what happened in the test tube B? The reaction did not happen. Now, why did not happen? Because you need sunlight for that reaction. This one is a substitution reaction. So the conditions were not right. So we can just say that the conditions are not right for the reaction to occur. So that is what happened in this first part of question 4. Let's go to question 4.4. which is a different story. I think this is the one that can give you a little bit of trouble. Let's consider the diagram below, and we have this diagram. Okay, so we're starting with an alkene, and now from alkene we go to compound X in this direction. You can see them, and we go to 2-bromobutane in this direction. Both ones started with an alkene, so we started with a double bond. Guys, it means that reaction 2, here I'm going to erase that one, this one is an addition. In actual fact, they are telling you is hydration. Remember, if it's hydration here, like they say, then you add in water. That is the one, okay? Now, reaction 1, they are not telling you, but because of the fact that we're starting with an alkene, it also means this one is addition. Note, I'm not answering anything. I just trying to analyze what happened. So we have two additions, 1 and 2 are addition reaction, because we end up here, we end up with 2 bromobutane and there's only one bromo. There's only one bromo involved. This was hydrohalogenation. But as I say, I'm not answering the question yet. Hydrohalogenation. Now, question 3, they are telling you is substitution. We have here, we're going to have an alcohol. You're starting with an alkene, you add water. Guys, compound X is going to be an alcohol. This is alcohol. How do I know an alcohol? Because you're starting with an alkene, you add water, that reaction is hydration, you will get an alcohol. That is the product there. Now, if we look at reaction 3, we're starting with a haloalkane and we ending with an alcohol. This is substitution. They're telling you it is substitution. But now, what type of substitution are we talking about, guys? This is hydrolysis. And then to finish this small analysis, from 2-bromobutane, we go to compound Y through elimination. So, guys, what are they going to eliminate? You have a haloalkane. Quite simple. What can possibly they eliminate? They must eliminate hydrogen and halogen. So this is dehydrohalogenation. It's the opposite of reaction 1. So this is dehydrohalogenation, and then here's elimination. So from alcohol, what can we possibly eliminate is water, so this dehydration, and this is the reaction. So will be once more a alkene. Remember, this is alkene. And guys, because we always start with 1, 2, 3, and 4 carbon, we are going to have an alkene of 4 carbons. And this is a small analysis we did before we go on with the question. Now, the question says, name the type of reaction in reaction 1. Now, attention here. They say type of reaction. So don't go to hydrohalogenation because you can make a mistake. You know it's going to be an addition because you're starting with a double bond and you end with a single bond. So it's addition. So instead of writing hydrohalogenation, because maybe you can get confused, we can get confused, then I'm going to just write addition because I want to save that mark. So the reaction there is addition. We already analyzed the question. That is why it's good to have a look to the drawing quickly. Okay, state the reaction condition require for reaction 2. The hydration reaction that form compound X. Okay, they are telling you is hydration. So you know what are the conditions. There are 2 important conditions there. Only 2 conditions, guys. We need first excess of water. Excess of water, that is one of the important conditions. And then we need an acid as a catalyst. We need a catalyst. That catalyst must be an acid, which could be H2SO4 or could be H3PO4. Either one of them. They is quite simple. They state the reaction condition required for reaction 2, the hydration reaction. So you can say either one of the 2. You need excess of water and you need a catalyst. Okay, and this is one mark for saying that one. State the reaction condition for reaction 3. Now we're speaking about hydrolysis. That is why it is important always to do the analysis of this specific question. Now, what are the conditions for hydrolysis? You have two main conditions there. First, you need a dilute solution of a strong base. You need a dilute solution of a strong base. What are strong base? Guys, any group 1 halogen will be a strong base, like hydroxide, pardon. For example, like sodium OH, that is a strong base, or potassium hydroxide, that is a strong base. Any dilute solution of a strong base. But that's not all. You need a little bit more. So you need heat. This must also, this reaction needs mild heat. So I'm just going to write here heat. You need heat for that reaction to happen. That one is reaction 4.4.3 for reaction 3. It's quite simple. And draw the structural formula of compound Y and give its IUPAC name. Now, this one seems easy, but it's not. It seems like it's simple because you say, okay, but we start with this one, we end with that one. Not necessarily. We have to look and analyze. We have 2-bromobutane and we go to an alkene. So let's start from that reaction. Reaction 4 will help us to get the answer of compound Y. We have 2-bromobutane. So let's do the reaction for 2-bromobutane. Now, remember, writing the reaction is not part of the question. The question says write the product, but to get the product it's better if you write the reaction. So we have this, which is a 2-bromobutane. They're giving you that one, 2-bromobutane. That is the compound that had formed through reaction 1 or 2. Okay, so there is 2-bromobutane. Now, this is elimination. We are going to take away bromine and we're going to take hydrogen. Alright, now for this type of reaction, which is dehydrohalogenation, remember you need a strong base. So we're going to add NaOH. It doesn't matter, it's not part of the question, but this is concentrated NaOH, which is a strong base. Okay, that is important. That is the difference with reaction 3. That one was dilute, this one is concentrated. And then what we get in the product. So we'll get still the 4 carbon, 1, 2, 3, and 4. There will be more products. I'm going to write it at the bottom because of the space. Okay, now the bromine is for sure going to go away. All right, but now remember we have 2 possibilities for this compound to form. Okay, we have 2 possibilities. We have one hydrogen here and we have another hydrogen here. So we look at the carbons. All right, this carbon have 2 hydrogens. While this carbon has 3 hydrogens. So we are going to take the hydrogen from the carbon that has the less number of hydrogen. In other words, we are going to take this hydrogen away. Alright, so saying that, then this hydrogen is still going to be there, but now here is going to be a double bond. Double bond there, single bond. This is the compound that is formed. However, this is not the whole reaction. Remember, you will have NaBr. This is coming from the halogen that you remove, and then you will have H2O. This is the complete reaction, but it's not part of the question. The question is said, write the structural formula and the name of the compound that is going to form. We go back there. Let's see the question. The question say, draw the structural formula of compound Y and give its IUPAC name. So this is compound Y. This one is compound Y. And then the name is going to be butene. That is the name. Guys, we are done with this question. We can see that we started with that specific compound. We ending with also an alkene that have 4 carbon, but not necessarily the same. Guys, this is all. I hope it helped. This question could be really problematic. So pay attention and try to do as many questions as you can. Thank you for watching. Don't forget to subscribe for the channel, to share the videos, to thumb up, to write comments. I'll help you if you need any other question, and then I'll see you next time. Mr. G here.